Okay, we'll get started here. I'm recording the session now. So, what we're gonna go over today is extending the partition. Remember, we played around here last time and created new partition and all that. But let me know this time we're gonna create the partition. Okay, so let's see here. We type df hyphen h. It will tell you what all the disks are there. But here in actuality, let's see. Okay, so this host has this is the operating system drive. On top of that, it has one, two, three, four, five, another five disk. Okay, so but what we are doing here is we're using only one, two, three disk. Oh, did I went this over last time? I think I did. Did I? Yeah, I'll go over it again anyway. So let's take a look at this here. So SDD1, okay, it is 8 gigabyte of hard disk space, and then we are using only 4. Okay, so let's make sure are correct. Type fdisk hyphen L, and then you could type this too. Okay, so the total size of the disk space is 8 gigabytes. Can you hear me at all or no? Can somebody confirm?
Yeah, I can hear you.
Okay, yeah, everybody please confirm if you could hear me or not, or put it in the chat. Yakub, can you hear me? Okay, so I see two people could hear me clearly, so I'll take it as yes. Okay, so you're with me so far, right? Out of 8 gigabytes, we have used only 4 gigabytes. So we could do that because we made the partition. Now, what happens if all of a sudden all this data is all full and it's up to 100%? Let me see how I could mimic that. Okay, let's see here. LVM dismounting. Okay, what I'm going to do is the size of this disk is this one SDD1. This partition is not even being used. It's being used only 1%. So I'm gonna fake it out and make it as if the disk is full. Okay. So let's see what I could do here. Don't worry about this. This is the command I have here, but I will go over that later. Okay. This is one of the commands to make it or mimic that we can now telling the system that this is we are making this drive full. So let me actually get out of it, and I'm gonna go into this drive. I'm gonna go into this folder here. Okay, CD. Okay, I'm gonna go ahead and remove everything from there. Nothing is there, right? Now I'm gonna run the command. It's a particular set of command here. I think I told you before too. Okay, we're using this command to make a junk file that would be about a size of 4 gigabytes. Okay, so we'll take a look. It will take a few minutes. Okay. Okay. Now, can you see me here? It says 100% full. Okay. So what will happen is you will get a request from the users that the disk they're using is full. Okay, before we ran this command, we look at it here, it was using only 1%. Now, what you have to do is you have to find out what physical disk this partition is using. So what you do is, it's a dead giveaway right here. Like when you see SDD1, that means it's probably one partition on the drive SDD. Okay. So what you have to do is you don't know if there is more room or not. So what you have to do is just type fdisk -l, and then you type this /dev/sdd. Okay. Now you come here and take a look. Oh, okay. This disk has about another. It's using 4 gigabytes, and it has another 8 gigabytes of data available. Okay, or the disk space is available. So we're gonna go ahead and increase the size of this from 4 gigs to another 2 gigs. So what you have to do is, we are on number 3. So very first thing you have to do is unmount the disk. Okay, so you could run this command or you could just run it on here. So what you type is, you get out of here, you type umount /Chris, and you type df-h. Okay, this line shouldn't exist when I run this command. Okay, and it has indeed disappeared. The folder Chris, which is 100% full, is gone, but it's not physically deleted, it's still there. So what you have to do is you have to run the fdisk command. Okay, fdisk space /dev/sdd, right? And you hit enter, and then you could see M for partition. So what you want to do is delete and recreate partition.
You'll make N.
I'm sorry?
You will put N, yes?
Uh, no, so what it says here is you have to delete the partition. So
D.
let's go ahead and delete the partition and recreate it again. So to delete it's D. Okay, and then let's take a look if the partition is gone, and the partition is gone. So what we're gonna do is create a new partition. So what is the option for creating a new partition? Add a new partition. You type N and hit enter. Okay, and you're gonna make a primary partition P, enter, and then there is no other partition available, so we're gonna use number one, and then we hit enter for default, and then we use plus. It was 4G, right? So we're gonna make 6G. We're adding another 2 GB and hit enter. Okay, then you do P and hit enter, and you see the partition size is 6 GB. It used to be 4. We still have 2 GB left in there. And then to exit out of this, you have to type W to make the changes, to write the changes. Okay, so it has done what it's supposed to do, and we're back to prompt here. Now you have to run this command here. So you need to resize. So when we type df-h, the disk is not back yet because it's not ready yet. So what we're gonna do is, this was unnecessary. I don't know why it's there. So this is a resize command. Okay. Oh, I'm sorry. This is a resize command, but you still have to run this command also. What it's gonna do is it's gonna check the file system. E2 fsck -f, and we're going to run it on this drive. Okay, and hit enter. Okay, now you have to run the second number 13. This is the command exactly you have to run. Can you mute yourself? Okay, so let's see, let's do fdisk -l, then /dev /sdd1. Okay, when we run that command, we are only checking for SDD1 partition. So it's telling us it has a 6 GB of partition available. So let's see here what's in the cat etc fs tab. We did made it a permanent that Chris is mounted to this drive here. So what is the command to automatically mount this, whatever it's in here?
Mount A.
Exactly. Mount -a. And we type df-h, it's there. Now you see, why is it saying only 70%? Why is it saying 70% used, not 1% used?
Maybe because you didn't format it, you have to format it.
Exactly. You got it. If we go in there, hopefully the file should still be there. Remember this file we created earlier? We went on a very risky journey here. From here to here, we went on a very, very risky journey. And then even after that, the file is still there. If you would have run the command, the previous command I showed you last week, which is uh, this one, mk2fs.ext4. If you would have run the command here, it will it will destroy everything on it. It will just wipe everything off of. Even though we deleted the partition, the partitions the data is still there. There is still hope for a data to be intact. Okay. Any questions? If you want, I could go over this again one more time. We could play around with this disk here, SDB. Now I think it's already been used. 2, 4, 6, 5, 6, and yeah. What we could do is we could create another blank disk and then go over this again. Or it's clear here. Should I go over this again or not? Let me know.
No, it's up to you, Zafar. If you want, format this. It's up to you. Fine.
Okay. Anybody else want to go? Okay, I'll go over it real quick, okay? Okay, so let's see, yes, we're going to work on same disk. And this disk I know is 8 gigabytes, only 6 gigabyte is being used. Okay, so what I'm going to do is, see it's 70% use, and then when we're going to add another 2 gigabyte, it should come down to 50%. Okay, so let's try from top. Here it's telling us to unmount it, so you have to just unmount it. You mount, either you could type Chris/Chris, or either you could type this. So last time we tried this/Chris, right? So this time we're gonna try this and hit enter, and then you have type df-h. It's still there. Can somebody tell me why I'm not able to unmount it?
Because you have to go to the root. You are
Yeah,
inside the code.
exactly. You get out of there, and then you go up the command and type it in there. Df-h. It's gone. It's not deleted, but it's not showing in there. Okay. Now what you have to do is type fdisk slash dev slash sdd 1. We're not going to type sdd1. We're just going to type sdd because we're going to go look at the entire physical disk. Okay, and then we're going to go p and we'll look for the partition. So the partition is only 6 gigs, but the disk space is 8 gigs. So what I'm going to do is I'm going to go into the menu again, and then I'm going to delete the partition, and then I'm going to see if the partition is gone. Yes, the partition is gone. Then I'm going to create a new partition. What is the menu for the new partition? N as in Nancy. I push N and hit enter. It's telling me which partition you want to make. I push P for primary and number 1 for 1 because there is no other partition. And then it's asking you, do you want to use the default cylinders? Yes. Now I'm going to what I'm going to do is I'm going to type plus I'm not going to type anything. I'm going to just hit enter because it should take the entire disk. Okay, using default value. Let's do P and hit enter. See, it's taking up the entire disk space. When you don't type anything here, usually plus in gigabytes, 2, 3, 4, or whatever, that's going to take the entire disk. Okay? So we have completed this part here. We resized it. And then you don't need to you mount it here. Okay, then I'm on number 11. You definitely have to run this command. Okay, so what you do is you do W to make sure it saves the changes. Okay, now what I'm going to do is I'm going to type this command here on number 12. So in actuality you just type same exact command here the way I'm typing, E2FSCK hyphen F dev slash sdd1. Okay, and hit enter. It's going to run through some checks, and then it will come back and tell you if there is a problem. It will tell you. Okay, so it patch 1 2 3 4 5. Okay, so we are not done here yet. So the next command is on number 13. Is you have to type exactly the way it is, resize to fs. Okay, slash dev slash sdd1, and hit enter. It's resizing the partition, and it did that. uh, okay, so it's kind of telling you like it has added another 2 gigs of disk space. So the file system on HD1 is now 2 gig blocks long. Okay, df-h, it's nothing there. So mount -a, df-h, there you go. It's back to 8 8 gigs is disk space, total gig space, and 4 gig is being used, and another 4 gig is left. It's about 50%. 50% of the disk space is still there. Any questions?
Okay, Zafar, in this case, like you are securing the old data, yes? Because you call it from the disk.
I'm doing what?
You have secured the old data.
Yeah, yeah.
You call the old data from the hard disk.
Yeah, it's still there. You see, this
Yeah,
file is
because
still there.
what we did last time when we add like you remember in the previous class when we add 4 gig 4G or 6G, we were like deleting the previous one. You remember, like we said, but in this way it's different, like where you secure the data, yes?
Exactly.
Okay.
When you delete it, so that's why it's called extending the size of the partition. We are extending it.
But that one, the previous one, you said like you are restarting, or what you call it? You are
Reformatting.
reformatting. Yeah, exactly.
So here, as long as you don't run this command mkfs2 mkfs.ext4, you're kind of in a good shape here. But you still have to remember what the partitions were before. So about here, we're gonna work on this later. So I have a note here. It says inodes will increase automatically, so it will adjust itself. Okay. And we didn't compare earlier how much the inodes were, but the system is sensible. It kind of detects how much inodes the system needs or the file system needs. It will assign them any inodes to that file system. File system in other sense, the disk space. Okay. When there is no partition, anything like that, you can't call it file system because there is nothing on it. And then down on the bottom, if you recreate a file system, all data will be lost. What I mean here is if you have run if you have run this command, this is nothing but creating or recreating a file system.
Yeah, because you said last time there is two way. Like sometimes maybe the inode will be more, but the gigabyte it's okay. And sometimes like the size of the one will like of the file will be over, and you have two way to be like increase size it or increase it. Yeah.
Yeah. Suppose the disk is full, right? The disk is
Mhm.
full, but you cannot increase it anymore. So what you have to do is you have to start using the logical volumes. That's what's exactly is on next chapter. So what I'm gonna do is what are logical volumes is. I'll explain it here.
Zafar, how many giga for Bashar 3?
You tell me. You take a look at it and tell me. Are you looking at?
Yeah,
Okay. So what information are you looking at right now with the highlighted one?
it has used 3,000, what, 300,000 inode
Okay. Yeah, I got it.
out of 300,000 32.
Yeah. So
Still,
remember.
there is some room in the inode, but it looks at the gigabyte, it's full. You can
Oh,
mention DF
no,
that what?
no, gigabyte is empty almost. This is gigabyte.
Ah, sorry, I didn't look at the up the previous one. Ah, okay, as in the inode full. Yeah, yeah.
Okay.
That's why you said sometimes they will call you and they will tell you we have problem, but we have still some sites. But they create a lot of uh, rubbish files.
Exactly.
Okay.
So whenever you get a ticket, it says that they will tell you or they will tell you anything. You don't just believe what the ticket says and what the application team are telling you. Okay, you do your own investigation and check it out and do your trust your instinct. If somebody's gonna tell and tell okay, I know is busy, or they will say okay, the disk space is full, but yeah, actually have to find out what the problem is. Because the application team people they don't know, right? I mean, they're just worried about their own work. They're not worried about other work. So okay, shall we move ahead?
Yeah, okay.
Okay, so what I'm gonna do is okay, umount hyphen a. Okay, fine. Okay, when you type umount hyphen a, any additional drives, all these drives are gone. I mean, it's not gone. It's unmounted, except the operating system drive, which is this one. Okay. So what I'm gonna do is we're gonna work on the logical volumes. So give me 1 second here. So what I'm deleting is I'm clearing everything up, deleting everything up, and then I'm gonna demonstrate how to create a logical volume. Okay. So what I'm gonna do here is I'm taking like three physical disk. Okay. So what I'm doing is three physical disk. Well, here, let's see here. What I'm gonna do is I'm gonna take three physical disk. Okay. Eh, can I change the color? So I'm gonna take three physical disk like this, and then these are 8 GB each. Okay. So let's see here. So it's nothing is there. But let me type fdisk. Let me type cat proc partitions. So we have SDE there. Okay, hold on. Let me go ahead and delete SDE. Okay. Okay, we're gonna use B C D. I don't know why E is acting up here. Oh, E is can somebody tell me what E is? It's a swap disk. Remember we created a swap? Let's see, fdisk hyphen L slash dev SDE. So if you do P, it's not printing any information here because it's a swap file. So let me exit out of it. We have something here about swap. So here. You know what? Let's not mess with that here. So let's leave that alone. We'll work on the logical volume manager. So you get the idea, right? You have the three disk, and then I'm going to use 3 disks here. One, two, three. These 3 disks, I'm going to run some commands and make it a one single disk. Okay, I'll show you how is that possible. So what you have to do is you got three single disks. So what you do is you go in there and create a partition the old fashioned way using fdisk command. Okay, and then set the hex code to 8E. That's a code. So let's see here. Cat proc partitions. I'm gonna use BCD. Okay, so I go fdisk slash dev slash sdb, and I will hit enter, and it comes up here, and then I'll push M for menu, and then it's telling me to create a new partition. So let's see here if there is an option for something else. Add a new partition. No. So we'll go with N. Add a new partition. N, hit enter. It's going to be primary partition. P, enter. 1, enter. And then default cylinders. And then we're going to use the default. And then we're going to use P. But by default, it took the ID 83 because it's taking default. So what you have to do is you have to come here and type menu, and then you have to go and select T to change the partition system ID. What we need a partition system ID? We need partition system ID as 8E. It's saying LVM. That means logical volume manager. Okay. I mean, it sounds ridiculous here what LVM is. Then you probably have to look through it and then what I'm doing, and then go through on this on your own couple times. Then you will realize what a logical volume is. Okay, so I type T and hit enter, and then it's telling me hex code. Hex code we already know is 8E. Okay, and I hit enter, and then I push P, and then it changed the hex code to 83. That's what we want. Oh no, my bad. We don't want 83, we want 8E. So let's look at a menu here, and then list of known partition. So 881, 83 is totally different than 8E. Do you see 8E somewhere here? 8E. 80, 83, 8E right here. Linux LVM. Okay, so we're gonna set that up. To do that, you have to type T and type 8E. Okay, then you took P. Now it's actually changed to 8E, and the system volume is Linux LVM. Okay, so if we quit here, it's not going to write anything, so you have to type W and hit enter so that it will hard code it. So we're going to go in there and do it for other drives too. I'm going to go fast here. Okay, and then I'm going to just see if nothing is there. So I'm going to create new partition. I'm going to create primary. I'm going to create number 1, and then I'm going to hit default. Okay, and then it's telling us is going to use the default value, and then we're going to go T and hit enter, and the code we need is 8E, and then we push P again. It says Linux LVM 8E ID, and then when you type W and hit enter, it will write the changes to the disk. Okay, we're going to go up there and use D. Nothing is there already, so we're going to create new, and then we're going to go primary, and then we're going to 1, and then hit enter again, and then it says last cylinder. Okay, so I mean, if you want, you could give the number here, but we're going to use the entire disk. Okay, hit enter. Okay, and then we're going to go print, but it has a ID 83. So we don't want ID 83, we want ID 8E. So how are we going to do that? Type M, and then the menu we're going to go into change that is T. So you push a small t and hit enter. Now it's asking you the code. 8E is the code. Okay, again, before I exit here, let's go back and take a look at what 8E is. For you to find out what AE is, you type L here. List known partition types. Okay, and then you have 8E somewhere here. 8E, where is it? Just had it right here. If you want to change it to some other partition, I didn't even use this in my life here. AIX, all this fun stuff is there, but we are not worried about that. Now we are worried about this partition. We are worried about this one, which is a default one. If you don't give anything, it will take this one by default, 83, and then the swap one. Can you see the swap? Uh, where is swap? LVM BD. Yeah. Well, I'm not worried about it now. So just to push P and then make sure 8E is there before you type W. Okay, what W is doing? W, when you type W, it writes the whatever the changes you want, it saves it to the table and the disk, and it exists. Okay, it's doing two or three things at the same time. W enter, so it writes it and makes it permanent. Okay, so when you type fdisk cat proc partitions, there you go. We use SDB, we use entire disk, and we created one partition. We use entire disk for C, and we use entire disk for D. Okay, everybody with me so far? This is really important. You come back to this page, LVM, Logical Volume Manager. From the drop down, you come here and look for LVM. I would suggest you practice this every day until you get a job. Come here, add like 5 disks here, and then come in here and follow the steps I showed you so far. Okay. Okay. So now the fun part starts. So we have done this, and then we have done this also. This command is nothing but this command here, bcd. Okay, we already came here and verified we're going to use bcd. Okay, so we have used bcd, b, c, and d. Okay, and then what we're going to do is, okay, and it says let's use this to create a volume. First, you need to prepare a disk to be added to the physical group. So what you have to do is you have to run this command, pv create. What does pv stands for? Physical volume. Okay, so you type pv create sdb, just type the whole thing, /dev /sdb, and hit enter. I typed the wrong. Now it should work. Oh no, I'm sorry, sdb1. Okay, so it successfully added a physical volume sdb1 okay, to the group. Now I'm going to do SDB, uh, SDC1, okay, and then I'm going to use SDD1. So what just happened here? What just happened? Okay, you kind of confused, right? So for that, what you do is to look at the physical volume, PVS. Okay, let me explain you. When you run this command here, PVS, these three commands here, one, two, three. Okay, I'm sorry, one, two, three. Three commands. Each time you ran, you made it a part of LVM, 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 but they are still independent here. So what we're going to do is we're going to bring them together with some other commands, and then we'll make it a one disk. Okay, you will see it on a you will see it when you we continue on here. Now we need to add these two disks to the volume group. Okay, so let's do that. VG create. Okay, and then we could give the name, we could give the name to this disk here. So we have three disks, we are combining all three disks together, and we are making a group. So once we have a group, we could actually name that group. Okay, so we're going to name that group ZMPT1. Okay, and then which disk you want to use. You want to use like as little as two disks, or you could have like as much as three disks in there. So we're going to add three disks together in there. Okay, does it make sense here? What does VG means is volume group create. So it's a single command, VG create, and then we are giving the name. What do you want to name the volume? You could name anything you want. You could name it Bashar, but you just have to remember it. So to keep it professional, I'm just giving it a name, ZMPT1, and then we are adding three disks to this group. And let me hit enter. So it goes through a few milliseconds, and it says that the ZMPT1 is created. What ZMPT1 now is one single disk. So can somebody take a wild guess? What would be the size of this ZMPT1? Bashar. Just a simple logic.
24?
Yeah, exactly. You got it. So now I'm going to run the command here to see the size, right? So what is the command here? The command to see the disk information is VG display. VG volume group. We used here VG create, right? So VG display is the command. It stands for volume group display. ZMPT1, okay? And hit enter. So you could see here, it's giving you some information here. It's telling you volume group name is ZMPT1, and it doesn't have a system ID. And what kind of format is it? Format is LVM2. Why is it saying LVM2? Because we gave it a ID LV8E. Okay, so it's going to go through LVM2, and then it has some information, and this is readable and writable, and the size of this disk is resizable too. Okay, and then volume group total size is 24 GB. Why is it 24 GB? Because the total of all three disks. Here we type three disks. One, two, three. What we did here is we combined three disks. One, two, three. Three physical disks. Okay, are you with me so far? And these are some other UUIDs. I mean, these are like system generated information here, but most of the time what you're really interested in here is this information here, okay? The size of the three disks together is 24 GB, but that information is not enough here, but you don't know which disks are in there, right? You just see VG group. Okay, so let's see here if there is another command. Um, let's see VGS. Okay, there is another quick and dirty command here. You type VGS, and it will give you the short information instead of long information. It gave you short information. You see VG stands for volume group. That's the name of a volume group, and then physical volume. PV stands for physical volume. Physical volume means how many physical drives it has in itself. It has three physical drives in it. Why is it saying three? Because up here we told the system VG create command to use three disks. One, two, three. Right here. One, two, three. Three disks. It used three disks. When we come back here and add the fourth one, it will tell you four. And it says logical volume 0 because it's not being used yet. And then it has some other information. I don't even know what it is. And volume size. V size, what does it mean? Volume size is 24 GB. Okay? And then right here is how much it's free. So, when you type df-h command, it will tell you how much is there, how much is available, how much is free. So when you type VGS, it will definitely come here and say, don't worry about this. This is always going to be there. It's a system drive. Okay, that one which I just highlighted here, this one is this system drive. You don't have much control over it. It's automatically created by system. Okay. So next command is now we're going to create a logical volume from this chunk of volumes. So what we're going to do is we have this big volume here, right? 24 GB. So we have how much? We have a big chunk here. And then physically it has like three drives in it. One, two, three. So 8 GB each. 8 GB each, okay? It's all 24 now. So what we're going to do is, right now this is what it looks like, a big old chunk. Big old chunk. Like a block. It's not usable yet. So what we're going to do is, we're going to use these commands here, lv create, and then we're going to make it a disk out of it. Okay, so watch out. LV. LV means logical volume, create, and then you type -n, we are creating something new. And then again, we're going to give actually this is like a partition. We did a partition long time ago. We did a partition on one disk. We did a partition SDD1, SDD2, SDD3, right? On a single partition, on a single drive, you did three partitions. Now we have a big chunk of multiple drives, physical drives, and then we could carve out of it another partition out of it, okay? So to do that, we are using lv create. and then we're gonna give the name. We could freely give the name here, so we're gonna give the name data underscore test hyphen L. So it's a capital L. And then what is the size of our disk normally? Physical disk. Anybody? In this example, normally what is the size of our disk here? Extra disk, what is the size here? 8 GB, 8 gigabytes. Now we're creating a one big old chunk here, so we could create as little as 1, or we could create as little as 12. And then we have to tell them where you're going to carve this out of, where you want to make this block out of. So you want to make this block out of ZMPT1. Remember earlier we have ZMPT1 is a big old chunk of disk space. It has 3 physical disks in it. Normally the most we could go in this scenario is 8 GB. Now look what's happening here. We could have up to 12 GB because this size is 24 GB. It's acting as one single drive. It's not acting as 3 drives. It's acting as a one single big drive. Now what you could do is there is a requirement here that says 8 GB doesn't work for certain application, but you need 12 GB. Okay, but you want to give 12 GB. Okay, so you have to go add another 8 GB, but you don't want to use another 4 GB, right? You could use another 4 GB for something else. So for now, what we're going to do is we're going to use 12 GB to make it a block, standalone block. It's called data test, and hit enter. Okay. Okay. So we got a message that says logical volume data test is created. You guys could still hear me? I got a message here, a network error. Hello? Hello?
Yes.
Yeah, I can hear you.
Yeah,
Oh,
we can hear you.
okay, good. Okay, so we are here. We're on a part two here. This is part one. Part one we did like about 21 steps here, and we are on part two, like building logical volumes. So we did this number two. So this is like a broken down. This is like an explanation what this command is doing. This is a single command here. The whole line is a single command here. And we got a confirmation here that logical volume data is created. So how are we gonna know, how we gonna take a look at this? For that you type lv scan, lv scan. LV stands for logical, V stands for volume. Scan is a regular old scan, scanning the disk. Okay, and hit enter. So what it does is it goes and look for the LV scan. So we have something called LV scan is about 12 GB. This is what we exactly created here. And the same thing comes back and gives information about the root, because when we run the disk very first time when we install Red Hat, it automatically does its thing and then creates a logical volume. This is nothing but a logical volume in itself. Okay, remember that. And then swap, since swap is also a logical volume because we are cutting that volume out of a physical drive. but it has done its job. It's a different way to create a swap here. So swap, the root disk, and then the LVM, they all function the same way, because you could increase the swap anytime, right? And then you could also increase the size of this, but most of the time it's fixed here because it uses up everything. It's probably using the entire disk space. Yeah. Okay, let's move on. So when you have a partition, you still have to format it, right? So remember this command, our good old command. So let's see here. Uh, cat proc partitions. Okay, so this is not the VG. What was the command there? Volume group VG display. Okay, I'm trying to see if VG display has any more information here. Okay, so we were here, it displayed this much information, and this is a new information here, right? Let me determine if this is anything different. Okay, let's see here. VG display, red hat. Okay, so what this is this is actually the information of this disk. It's throwing this information here. So we're not worried about that. Okay, so what happened now is we have to format it. This is a format command, mk2fs. What it's doing is it's adding the, no, it's preparing the disk. We ran this mkfs.ext4 on a physical drive, right? When we were making partitions, this is the same thing. And then always remember, any disk that starts with dev, even though we don't have a SDB1, but we will start with dev and then the volume name, zmpt1/data. Oh, I'm sorry, I'm over here now. I'm over here. Okay, and hit enter. So this command, it ran the same things, it threw out the same information as if you would type this command. Remember, we have run this SDD1 last week, so it would have given us the same information. I'm not going to run it now. So let's do LV scan. Okay, so I'm looking at this information here, it didn't change it, because this is the information we just used to create a to format the drive. Now this is going to act as a single drive now. Okay. So let's see here. We had the folder Chris, right? So what we're gonna do is we're gonna go in here and then just replace this with this. Okay. Okay. Is it making sense? The zero zeros here because this is long. It came down here. There's zeros here. It came down here. It's fine. There's no problem with it. Okay. And then you save and exit out of it. And you type df-h. Df-h. There's nothing major in there. Okay. So you type mount-a. What will happen if I type mount-a? Okay, see now this ZMPT1 this data disk is mapped on Chris. I think everybody is confused here now. So what I'll do is I'll stop here and then I'm going to go over this again tomorrow. Okay? That way I'm gonna have to create another one, like secondary one and all. That way you could explain it better. So I started number 7 and I mounted. What I did was here is a good old mount. This part should be clear, right? Anybody has any questions about mounting the logical volume?
No, fine.
Okay. Do you have any questions, Bashar, from yesterday? You were putting in the chat. You had some questions.
Yeah, no, no, but you know what? When you guide me, I was not formatting I didn't use the MKFS. When I did it, like when I format the disk, it works.
Okay, yeah.
Like yesterday when I asked you, you find out what you said you using absolute path. No, it's very sensitive. You really like if you forget single small thing, you will not be able to move forward.
Yeah, exactly. Well, small things will block everything, and then one small command will destroy everything.
But you know, it's learning. Really, same what you said. As much as you practice, you will find out. Like even when you're stuck, you will get to know more, like how to sort out the issue and get used to it.
Yeah, that's good. I'm glad you're getting good at it.
Thanks. This is with your instruction.
Yeah. So we have another half hour. I'm not sure if I should continue because what I covered today is a lot, and I want you guys to have some rest before we cover more. Because what I'll definitely do is tomorrow. mm,
Okay, Zafar, whatever you see, fine.
Yeah, because I mean this subject here is very important. I cannot stress. I mean the document looks only 3 or 4 pages, but only this quarter of we have already spent hour and a half, only just this much here. But we could have open discussion here. Anybody have any other questions, or how's the practice going on, or how's the assignment coming up? Anybody started working on assignment?
Actually, I was planning to start tomorrow, but I get stuck with the previous course. But I'm planning to start today or tomorrow maybe.
Okay.
But it looks fine. I read some question of the assignment.